So this lesson is on projectile motion from the perspective of a vector valued function. So we have here as the projectile is launched from an initial height of 3 feet. The initial angle is 60 degrees with the horizontal, and the initial speed is 100 feet per second. And we want to find the equation of motion. Well, one thing that we know, the acceleration due to gravitation on Earth at sea level is 32 feet per second squared, or 9.8 meters per second squared. So we're working in British units here. So we're going to focus on the 32 feet per second, but that's 32 feet per second in the downward direction. So the acceleration is all in the y direction. There is no issue in the x direction, but it is 32 feet per second in the negative direction in terms of height. So t is going to represent time, and this value is going to represent height. So where do we go from there? We want to go from the acceleration to the velocity. So we know velocity prime is acceleration. So velocity would be the integral of the acceleration factor. So the integral of that, the integral of 0 is just some constant c1. The integral of negative 32 is negative 32t plus c2. And then our goal next is to find out what c1 and c2 are going to represent. So how do we decide what the initial velocity is? You've got to do some trigonometry. We have 100 feet per second, 60 degrees with the horizontal. So the magnitude of this initially is 100 feet per second, and this is 60 degrees. So can we decompose it into what I'm going to currently call x of t and y of t? So what will those things be? So what is the x value here? What is the y value here? Well, what can we recognize? We know the cosine of 60 degrees is adjacent over hypotenuse is x over 100. So 100 times cosine 60 degrees is the x value. Cosine of 60 is the same as the sine of 30, which is just 1/2. So what do we get? We get 100 times 1/2 is the x value. So we get 50 is the x value for my initial velocity, right? At that time 0, my initial velocity, the x value will be 50. Now, how about the y value? How is that going to work? What are we going to do there? Well, sine of 60 is opposite over hypotenuse is y over 100. So 100 times the sine of 60 degrees is y. 100 times root 3 over 2 is y. So 50 root 3 is y. So that's my initial velocity. So, I mean, how do I really sell this? How do I emphasize this? My velocity function at time 0. The x value is 50, and the y value is 50 root 3. So we need to use this fact, and we need to use this fact before we make our next move. So we have velocity of 0, and we have v of t. So let's see where that takes us. So we're here. So our next move is to go ahead and replace the t here with 0. So using this model, what is the velocity at time 0? It is simply c1 negative 32 times 0 plus c2. So my velocity at time 0 here is C1 comma C2. But my velocity at time 0 over there was 50 comma 50 root 3. So we see these things have to equal each other, which would then tell me that C1 has to be 50 and C2 has to be 50 root 3. So it enables me to determine the velocity function of this projectile motion. So V of t is C1 50 comma negative 32t plus C2 plus 50 root 3. Well, velocity is the derivative of position. So the position function R of t would be the integral of V of t. So what would that be? The integral of 50 would be 50t plus another constant, which I'm going to call C3. The integral of negative 32t would be negative 16t squared plus 50 root 3t plus another constant I will call C4. Great. Now where do we go from this? Well, if we go back to the original, what did it say? It said the initial angle was 60 degrees with the horizontal. We use that. It said the initial speed was 100 feet per second. We use that. But it also said the initial height was 3 feet. So my initial height is 3 feet. So what is my R of 0 going to be? We assume that our starting point has an x value of 0. We're going to define where we're starting at. Our distance from the starting point will be t, so therefore our starting point would be 0. But our initial height is 3. Now, using R of t up there, what is R of 0? 0 plus C3, 0 plus 0 plus C4. Putting these things together, then we can see C3 has to be 0, and C4 has to be equal to 3. And that gives me my position function. R of t is what? R of t is 50t plus C3, so it's 50t, comma, negative 16t squared plus 50 root 3t plus 3. That gives me my equation of motion. But now there's some questions that we could ask. Namely, what is the maximum height of the projectile? And how far from the launch pad does it land? So how are we going to answer those questions? Think about that for a few seconds. The maximum height of the projectile. How are we going to find that? What is our strategy going to be? The height is here. So when does that achieve a maximum? What value of t gives me a maximum? What tool from calculus can we use? And how far from the launch pad does it land? How do we answer that question? Well, what does the height have to be for it to land? See if that's enough to give you an idea in terms of where to go next. To answer the maximum height, we need to find out when is this maximized. So let's just go ahead and call it f of t is negative 16t squared plus 50 root 3t plus 3. What is f prime of t? That's negative 32t plus 50 root 3. How do we maximize this? We find a critical value, set the first derivative equal to 0 as we go back to previous calculus courses. And solving that using our usual strategy. We get the value for t. And we recognize by the second derivative test that it's negative, so we know that we have a maximum. So the height is maximized when t is 2.706. But what is that maximum height? You've got to plug 2.706 in for t. So what is f of 2.706? That's negative 16 times 2.706 squared plus 50 root 3 times 2.706 plus 3. And we get about 120.2 feet. I'm just going to warn you, this is assuming we're in a vacuum. This is assuming there's no air resistance. So this is certainly in ideal circumstances. But the second question was, how far from the launch pad does it land? Well, if that's the case, I need to find out when the height equals 0. So when does negative 16 t squared plus 50 root 3 t plus 3 equals 0? And what tool would you use for that? You would use the quadratic formula. So let's go ahead and jump to some help with that. Going to Wolfram alpha, negative 16t squared plus 50 root 3t plus 3 is 0. And you can see we have some exact answers there. The negative number doesn't make any sense, but the 5.447 does. So we'll say t is about 5.447. So how far from the launch pad does it land? How do I answer that question? I've got to look at this function, 50t, or maybe call it x of t, is 50t. So what is x of 5.447? That's 50 times 5.447. What does that give me? 50 times 5.447 gives me 272.4 feet. So that's about how far from the launch pad that it lands.